Okay. Hi, everyone. Can I grab your attention, please? I see a full class here, so I'm very happy. We're both stuck here at 7 p.m. So this is a very important tutorial. That's why, as I said, I'm going to give it myself, take all of your questions. Every single exam is going to have time complexity questions, right? Is my voice cleared or doing good? Okay. So every single exam, we're going to have a time complexity questions. Last session, we covered general, what do we mean by algorithm analysis? Why do we care about it? Why do we want it? And then we talk a bit about the mathematical background of it. But what matters for us is what are we going to do today? What actually matters when you're like analyzing the algorithm. We're not going to go through the math. We're going to just look at the algorithm and we're going to be able to just know this is big O of what. Okay? So I already released the tutorial without the answers, of course. Many of you asked me that, okay, they don't know how to solve it. That's fine because we're going to actually learn it today. The only reason I've published it is just for your own, if you want to start looking at it before the class. Now, what we're going to do, we're going to try solving things together. Okay, through the WOOC lab, and then I'll switch to the slides. I want you to all try to solve it. Now, how are we going to do that? It's better if you have a pen and a paper or your tablet. Okay, so it's interactive. So let's start first by okay, let me turn off these slides. Okay. It's here. Yes. Okay. So perfect. So let's start. First, few things I want you to know. So sometimes we're going to use pseudocode, sometimes Java, but what we care about is just the algorithm. We don't care. Let's say sometimes you may find a bug in the code. We don't care. It's okay. This is just for the sake of explaining things. Now, two main things that we need to know, some terminology. Some of you are familiar with this, some are not. When we have something like this, guys, 2 for loops like this, these are normal 2 for loops. When they are like this, they are called what? Nested. Okay, why do we care about this? Because when we want to start, first, before we go into the loops, these here are what? Sum 1 equals 0, sum 2 equals 0. What are these? Assignments, right? If you remember, we said we call it like primitive operation. We don't care about them. They are constant. Okay, so we can skip them usually. Or you can just write it, for example, as constant or whatever, but at the end, we're going to skip them. Now, the same thing for the return. So what do we usually care about is when there is a loop, because the loop is the one that is going to show us how long is our program running. So in this case, if I want to look here, this program starts with I equals 0. When is this problem going to stop? Raise your hand and let me know. Riley. Exactly, but I equal to n minus 1. Why? Because it's I less than n, not less or equal than n. So this is also something very important. If it was like this, equal than n, then yes, it's going to stop at n. In this case, it's going to stop at n minus 1. Why? Because we're starting from 0. So 0 is going to till n minus 1. That means it's going to do n time because we're considering the 0. Yes.
The last thing it's going to execute is for n minus 1.
Exactly. So the total will be n. Now, sometimes we start with 1, so it has to end with n in this case, not before n, because we started by 1. Okay, so that means we care about the start and the end of this loop. Now the second one, again, j equals 0, j less than n. So this is also going to be n, right? So this one is going to be n times n times. When we say it runs n, that means it's going to repeat what's inside this. So it's going to repeat this statement n times, right? Okay, when I don't have a nested loop, I have these for loops like this. I have n here, n here. What is the total? N plus n. So we use what? Plus. So it's going to be 2n. That means O of n. I don't care about the 2. Okay, very good. Now, the same thing, here is n, here is n, but they are nested. What do I use? Multiplication. So it's going to be n squared. So the thing that I want you to take from here, if they are nested, we multiply. If they are not nested, we just add. Okay, so that's the main rule when it comes to loops. We're all good? Okay. We're going to start now. So let's start with okay, so we're going to do them together. Start. I want every single person of you guys to try to do it. And then we're going to solve it together. It's very important, okay? And then you're going to solve it by yourself after that. Again, hopefully you'll try your best before tomorrow's lecture. I know it's short time, but why? Because maybe tomorrow you're going to ask me questions inside the class about this. Okay, guys? No worries. Another thing while you're doing this, I was asked about the assignment deadlines, publishing dates and stuff. So I've talked with the other profs. I just released on the announcement page tentative dates. It's not 100%, but these are the most probably is going to be like this. So 4 theoretical assignments and 2 programming. The first one is going to be released this Thursday, the first theoretical. It's going to cover algorithm analysis and stacks and queues, which is going to learn tomorrow. Tomorrow is going to be stack, queue, DQ. Okay, so we're all in. Okay, so let's start with this. Let's look at this, guys. Okay. Let me, where is it? This one. So what do we have here? For int I equals 0, I less than 10, I plus plus. Who wants to start with this? Raise your hand. No problem, come here. I'll start with you, yes. So dissect it for us so everyone can benefit. So you started with I equals 0, right? Exactly. So why did you say constant? Because technically, we know that it's going to stop before 10, right? It's going to run 10 times. We know it. So this is going to be O of constant or O of 1. So in the options, if I give you in the midterm O of 1 means O of constant, okay? Even though it's going to run 10 times. Now, guys, if I keep it I equals 0, I less than 1 million. Constant. I know 1 million. 1 billion, constant. Unless there is something which is variable or I don't know it, then it's going to be n. Okay, very good. So let's do the second one. Now, let's start with this. Okay, who can tell me, is this a normal 2 loops or nested for loops? Nested, very good. You want to do it? Okay, so let's start with the outer. We always start from the outer loop. So the outer loop is what? Very good. That's n. Very good. So what do I have? I have n and I have a constant. It's going to be n. Let's say this constant is whatever, 10, whatever, I don't care. It's going to be n at the end. So O of n. Is this clear? So we're going step by step. Things are going to get more complicated. Is this clear? Yes. Okay, so if it's 10n, it's going to be O of what? From the lecture we said. So very good. We said whenever you see, let's say a value. So I don't have some. So anything times n, we're going to write it as n. Let me write it 1 second. Okay, so let's look here. Let's say I have 10 n. When I say what is the big O here, it's going to be big O of n. Again, if you go back to the slides, you're going to see why. Now, sometimes we're going to have what? N plus 10. It's also big O of n. We only care about the number n. Why? Because if we say n is something we don't know, let's say n is infinity. So if I'm multiplying infinity by 10, it doesn't matter. If I'm multiplying infinity by 1 million, it doesn't matter. That's why. And if you remember, we gave an example. If you're working in engineering and robotics, if you're doing a surgery, biomedical engineering, you're just going to start to care about the 10n or 2n. But in general, we only care about the n. Okay, so let's go back. So this is 10n. Is it clear, guys? O of n, right? Okay. So let's start with this one now. We already kind of seen it. We just want to practice together. Who wants to practice with me? James, you know it, so I'm not going to ask you. I want someone who's still practicing. You want to try?
So again, this one, both of the for loops are on my end, so you know it's
Very good. So what do I want from you here? This, you look at it, it's easy. In the exam, for example, and actually in the companies that you're going to work with, things are going to be a bit more complicated, right? So I want you to analyze it all the time. Explain it. So now I want to explain to your friends. So it's easy, of course, n times n, but like, how are we looking at this? First, is this a nested loop? Yes. So if it's nested loop, then I'm going to multiply. That's why it's going to be n, nested loop, multiply. So that's I want you to think systematically. This is an easy one. Maybe you're going to be a bit complicated. Okay, guys? So anyone has any question about this one before we move? We all know why it's n square? Okay. Let's try this one. X equal 2, while x less than n, x equal 2 times x. Okay, think about it a bit, analyze it, and then answer. Let's give it a bit of time for everyone to think about it. So what are we trying to do? First, we want to see this while loop. In this case, it's not a for loop, it's a while loop. How many times it's running? Right? Who wants to think out loud? Who wants to brainstorm? Yes. Okay, I want you dissecting it, right? Doubling. Okay. Your friend here is saying, here maybe it's log n. Why? Because I'm not going linear. So let's say we're starting from x equal 2 till n. It's true that from 2 till n, right? So if I'm adding x plus plus, I'm going linear. So it's going to be n. But here your friend is saying it's going to be x equal 2 times x. So it's going to go double the time. So that means not linear anymore. Okay. A bit confusing. Okay. Let's look at this. Okay. So this, we know it. We know this, we know this. Okay, so this one. So what do we mean by log n? To refresh your memory is what? It is how many times I can multiply 2 by itself to get 16, right? Log of 16, it means that 2, 2, 2, 2. Log of 16 is going to be 4. So it took me only 4 steps to get into 16. If I'm doing it linear, how many steps do I need to do to get to 16 linear-wise? 16. I'm adding y because it's going to be 1 plus, 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 right? Here, it took me only 4 steps to get to 16. That means it's not linear. So the trick here is whenever we see multiplication or division, in these two cases, you're going to think logarithmic. Why? Because if I have, look, if I have here x equal x plus 1, this is what? Linear. This is O of what, guys? N. If I have x equal x plus 100, this is what? It's still linear. You think, oh, it's x plus 100, but it's still going up on the curve linear. So this is still going to be O of n. The only time it's not going to be linear, it's either when we have a multiplication or a division. So we're good. Now we may see another example. Okay. Okay. So this is going to be log n. Now, what is the time complexity of fun? First, what is the definition of fun? Is this today's tutorial, right? Okay. So what is the time complexity? It's a function. What is today's, what is the time complexity of this one? It's getting harder. Okay, so we learned the basics. Now, because I'm very nice, I'm going to teach you a simple way. Okay, so before we jump into the answers, so first let's see the answers. So majority of n square. Now, who said n square and want to tell me why it's n square? Yes. Okay. That's true. So now, technically, if you look at it, guys, int I equals 0, I less than n. So I'm going from 0 to n. The inner loop is copying j equal I. So whatever I is from 0 to n, right? So this is an easy one. We can actually guess it. It's n squared. But it's not going to be as clear as this. So we're going to learn a way to, whenever we see something called dependent nested loop, we're going to use the table method. So this is called dependent nested loop. Why is dependent, Riley? Exactly, because j equal I. So let's look at it here. Okay, so let's look at it here. Look here, guys. J equal I, right? So I have I here, I here. This is called dependent nested loop. Now, I know many of you, or all of you, are very smart and you want to look at it and solve it right away, right? And I trust that you can. But for the sake of the stress of the midterms, usually in the exams, try to do what? the table method, even if it will take a bit of more time from you. So whenever you see nested, we're going to go with the table method. So we're going to see what do we mean by table method in a bit. Now, first, let's go here. So ON square is the worst case time complexity. So among the given options, it can be what? It can represent what? ON square can represent which one of these three? So what do we mean by ON square? ON square mean big omega, big theta, or big O, right? So it means big O. Big O means what? Lower bound, upper bound. Okay. So guys, when I'm asking you ON square, that means I'm asking you, this is the upper bound. So my upper bound is ON square. That means everything below my upper bound can be what? Under this, right? So if we say, so think about it like that. This side building has 5 floors, right? If you're on the 5th floor, the roof of the building is your upper bound. But technically now we're in the basement. Are we under the roof? Yes. So that's what we mean here. So ON square, even if there is no here, it's O of n, O of 1, O of n log n. All of these are less than n squared. That means ON square represents them. Okay? Exactly. So the majority said all of the above. Now, which of the given options provides the increasing order of the asymptotic notation? It's not very clear, but so F1 is 2 to the power of n to the power of 3 over 2, n log n, and to the power of log n. So what is the question? Okay, so you have to do it in the increasing order. So we're not going to waste time of this. You just look at the lecture and you find it from the lecture for now. What is the time complexity of fun? Okay, so this is the dependent one. Okay, we're going to go and yes. Yes. So we're asking the ON square. It represents which one of the options as a upper bound. It represents all of them because it's the upper bound. Everything below this upper bound, it's represented by O of n squared. Yes. It doesn't have to be the best case, but which one of these, if I say is n big O of n squared, you're going to tell me yes, it can be. Even though it's not the tightest upper bound.
Thank you. So it's like if one is lower bound or average bound, it can be this for upper bound.
Yes, so the upper bound usually is above everything. Okay, so let's start with the fun things. Okay, guys. So it seems like there's this one before we move. Okay. So let's solve this one together, guys. Who wants to solve this before we move to the other one? James.
Yeah, it could be n log n because the first one's going to run for log n because it started n and start dividing until 0. I think.
And then the inside one is n.
Or n times log n.
And you multiply.
I'm sorry, but would it be n greater than 1 in that case? But it's going to be log n.
It's going to be what? Can you ask your question?
Otherwise, would it go forever?
I greater than 1, yes, most probably. Yeah. So these things, I usually do them without so sometimes there's bugs in this, that's fine. I just want you to understand the whole thing. So maybe you're correct. So let's take another one. Thank you, James. So who wants to also try to solve this? Let's check if there's more people. Yes.
First two, we're having the amount, so we're going to log n, and for the second two, we're going from 0 to n, so we're going n, and multiply with get n log n.
Okay. Who else? Or you all agree? What's your name? Abed and James. You all agree with Abed and James? Anyone has different opinions? We're a free country. No one? Yes. Go ahead.
Has to be greater than 1 equal to or greater than 4. Like,
Let's forget about this now. Let's forget about the if there is a bug or not. But I want you to know what is the big O of this. You know what I mean? Like just analyze. Let's forget if there is a bug or not. But like the first loop, what do you think it's happening? It's looping how many times? Okay, look. So let's rewrite this in a different way, okay? So I can write this for I, let's say equal to 0. I is less than n. I divide equal to 2. It can be written like that, right? What would this be? So it's starting from 0, right? It's going till where? Till n. Now, how is it going? Is it linear? Logarithmic, right? Very good. In this case, we can't work like that. It has to be times in this case, right? Because we flipped it. So that means this is going to be what? Log n. Okay, now the one inside it, the inner loop, for n j equals 0 till j less than n. Why? N. Why? So guys, listen, I want you to always ask why, even if it's clear. Why? I want you to just learn the systematic way. So the inner one, in j equals 0, j less than n. So it's going from 0 till n. How it's going? Is it linear? Because it's adding 1, right? J plus plus. So that means linear. It's going to be what? N. So now I know that this is going to be log n, and this is going to be n. Now the next step for me is what? I have two choices here, right? It's either it's O of n plus log n, or it's O of n log n. Which one do you think? Multiplication or addition? Why? Exactly. So do you see? It's just a way of systematically breaking down the issue, like the problem. Now this is clear. What if I give you something that has 4 nested loops? You know, there's many complicated things. It's better to divide it slowly. Okay, breaking it down. So is it clear now? Okay. Yes.
but to be in the log of n has to be 100.
Yes.
That is important. J is equal to 0. All 1 J's never left.
No problem. So usually these things, even if it's clear, sometimes it's hard to catch. That's fine. The most important thing for me now is that we understand logarithmic. Anyone is still struggling with this logarithmic? Yes. What is exactly you're struggling with? Which part? Okay, do you want to solve it together? Okay. Let's start. So what do you have here? We're starting from 0, right? So the first step that I want you to ask yourself, is this a nested loop? Yes, it is nested loop, right? So what do I do here? I'm going to multiply. So that's my first step. I'm done. Now my second step, I need to figure out this and then this one, right? So step by step. Let's figure out this one. It's easy. From 0 to n, j plus plus. So it's going to be what? N. Why n? Because I'm going from 0 till n like this. 1, 2, 3, 4. Okay? n. Now, this one, I'm going from n to 0. So I'm here. I'm just going backward. That's it. And I'm jumping. I can't jump. Okay? So what's happening here? I'm starting with n. I'm going towards 0. How am I going? Is it linear? Is it -1, -1, -1? No, it's division. So the trick here is whenever you see division or multiplication, you're going to think logarithmic. So now this is going to be what? Log n. Because we have a multiplication here, we're going to end up with what? N log n. Good? Better? Very good. Anyone else? Of course, yeah. Mm.
The second loop is also going to run for log n?
No, it doesn't have to be. It doesn't have to. Because they are nested loop. Technically, they are two separate things going inside each other. It doesn't have to. Yeah.
If it goes on forever, is it O of infinity or is it O of constant?
This is a philosophical question, so it means a philosophical answer. It depends how you're looking at it. So, but technically, yeah, it depends how you want to look at it from an engineering perspective, from a math perspective, from a computer science perspective. Okay, guys, so n log n. Now, I want to compare, I have two algorithms, unique 1 and unique 2. Both of them, they are doing the same thing, yes.
That would actually be designed to go on for infinity?
It's not supposed to be, because it's going to stuck in a loop. Or maybe there is, I don't know, to be honest. I don't want to give a random answer, but technically it shouldn't, because if there's something stuck in a loop, that means it's not good. Yeah. Let me finish this so we don't run out of time, and then we can. So what is the idea here? Let's take a step back, guys, and think why we're doing algorithm analysis. Why are we doing this? Because we want, before you start even coding, you're building a program, so returns true if there is no duplicate elements in this array. Let's say that's what I'm trying to do, this program here. And you want to present it to your manager, correct? But you know that your manager wants the best program before you start wasting time on coding it. So you're going to be prepared when you go there. You're going to create the first algorithm, create the second algorithm. They are doing the same job. And you're going to do the algorithm analysis. One of them has to be better. So Riley, if the first one took me O of n to finish, and the second one took me O of n squared to finish, which program is better?
Like the first one.
Exactly. Now, when we say which program is better, we're talking from a time complexity perspective only, because this course covers time complexity only. Okay? So let's start with this one. Okay. I want someone who didn't participate yet to start analyzing this. You don't have to solve it, just analyze it with me. Who wants to analyze it with me? Go ahead.
For the first loop, you're starting from 0.
Before that, I want to go baby steps. Hopefully, in the next week, we're going to skip all of these steps. But now it's the first time baby step. How many loops I have? 2 loops. Are they nested? Very good. Are they dependent or independent? Dependent, right? Okay. So guys, now you're going to decide your method. We know that these are nested loops, so multiplication, technically, but the most important thing, they are dependent. Who don't know why they are dependent? Raise your hand and I'll explain it to you. It's okay, guys, even if you don't know it. Yes. So why we say dependent? Let's look at it. J, right? Here I have K, but I also have J. That means this loop can't run unless it knows what J is. So it's dependent on J. That's what it means. Okay, good. Anyone still? Very good. Now, we want to do the table method for this one. So let's do it together. First, what's your name again? Taha. For the first iteration, what is j equal to? J equals 0, right? Okay, what's next?
So now when j is 0, then since k is also dependent,
Baby steps. J equals 0. So I'm going to go inside the loop. Exactly.
all the way to n minus 1.
Okay, you are the program. So your j equals 0. So you're going to enter the second one. So you're going to start with k now. The first loop is stuck at j equals 0. Exactly. K equal 0 plus 1. That's how I want like this baby steps. K equal 1. The next step, Taha.
So then j is going to go to 1 from 0 to
No.
2.
Take it slowly. Because these are nested loops. So guys, very good. Nested loops, j equals 0. I entered this, I'm here. I have to finish the first whole thing and then I'll go back to the j. Okay, guys, that's why it's important. This method, actually, the table one is take it step by step. So the next one, Taha, will be k equal what?
K equal 2.
2. Why? Because we have k plus plus. So we started with 1. Now, what is the next step? Who wants to raise your hand, guys? Let's see new people. Yes. K equal 3. Next step, k equal 4 till n minus 1. Very good. Why did we stop at k minus 1? Raise your hand and tell me why. Yes. Exactly. K is less than, not less or equal than. These are very important things, guys. Okay, we stopped at n minus 1. From now, from the upper bound of the class there, who wants to participate? What is the next step? I want someone from the last 3 rows. Okay, we'll come back to you. She saved you. Okay. J equal to 1. So I'm done from this. Now I'm going to go back to the outer loop. Now J. So this is my first one. So what happened here? First iteration. J equals 0 and then K. The first time, so the first time K was 1. The second time K was 2. The third time K was 3 until n minus 1, right? So how many times did we loop? N minus 1 time. Okay? So technically here, we're looking at this state. Now the next step is J equal 1. What is the step after that? We're back to the 3 last rows. Let's, even if it's wrong, just try to participate. Yes. K equals 0. 0? No. K equal J plus 1. So that means 2. So we're going to J equal 1 and then K equal J plus 1. So here is 1, 1 plus 1. That's 2. Okay, what is the next step after that? Yes? 3, and then you continue the same thing. When are you going to stop? N minus 1 again. Yes, right.
So we started 1 less than n minus 1. Now is it n minus 2? You write down.
Exactly. So now what's going to happen? So look here, guys. We started at 2 now. From 2 till n minus 1. How many times did I run? I just started 1 step ahead, right? Instead of starting from 1 till n minus 1, it took me n minus 1. I start from 2 now. So I skipped 1 number. It's going to be n minus 2. If I skip 2 numbers, n minus 3. I see lots of confused faces, but if you don't talk to me, I'm not going to be able to help you. Yes, Andre.
So is this the same as big O5 or early?
Big O of
This one up here.
this one can be similar. I don't know, but if we solve it, so this one we said we're going to solve because it's very clear. We can solve it without the table, but this one is not as clear, so we need to do the table. It's better. So what happened next now? For the third iteration, we're going to start with j equal to 2. And then k is going to start with what now? The last time, 3, right? Okay, so look what's going to happen. That's my third iteration. J is 2, I started with 3, n minus 3, n minus 4. Now, how do I solve? What is my big O? O of constant. There has to be something wrong, right? Doesn't make sense. Who can correct me? Let's let them think a bit. Who can correct me? Yeah, I don't know, maybe I made a mistake. I want you to correct me and tell me why. Okay. Raise your voice. Very good. Okay. So you're saying that why we're taking the last one? We want to take all of them. We calculated at each iteration, this is the number. But I want the whole program. I don't want what is the big O of iteration number 2? What is the big O of iteration number n minus 1? What is the big O of the whole program? Is what? Is the addition of all of this. So that means going to be what? N minus 1 plus n minus 2 plus till 1, right? So this is the same as 1 plus 2 plus 3 plus till n minus 1. What is this called? Math. Gaussian summation, or there's another name for it. So it's going to be n times n minus 1 over 2. This is going to be what, guys? N square minus n over 2. What do I care about here? The highest order, so n square. Now you're going to tell me, do I need to memorize this? To make it easy on you, you need to memorize only the math that I gave you in the first lecture. If you open the second lecture, the algorithm analysis lecture, at the end, there is section about math. So you need to be familiar with these math, which mostly are like series times something like quotient summation, other things like 2 or 3. But you need to be very familiar with these. Okay, now, is this clear? Yes. Very good. Guys, so let's all focus here. And if you have a question, ask me. So this is how many times this statement was executed at iteration number 1. This one here, how many times this statement was executed at iteration number 2? If I want how many times this statement was executed in the whole program, so I'm going to just add the number for the first iteration, second and third iteration. So the whole iteration, they concluded to this. So I just need to do the summation of them. So how do I do the summation? N minus 1 plus n minus 2 plus n minus 3. This is actually the same as I'm saying 1 plus 2 plus 3 plus till n minus 1, which is the Gaussian summation. So this is just a math equation here. So this one here is a math equation. We're good? Okay, let's assume each iteration was running n time. Each one of them, n time, n time, n time. What would be the big O? N cube? Why n cube, not n square? There's 2 loops. There's 2 nested for loops. So technically it should be n square, not n cube.
N time N.
Technically, that's correct if we're only looking at these two, nested loop, and so we can say it's multiplication. But if we're using the table, you're going to always just add up the numbers here. So if each one of them is n, it's going to be n plus n plus n plus n plus n. It's not going to be n cubed. So it's going to be, let's say, 100n. So it's going to be O of n, for example. Okay, so don't get confused. But anyway, it doesn't this forget about this example, do not get confused. We'll do another like this. Yes.
It's not 100 times, it's n times. So if you have n times.
Then it's going to be yes, but I'm just giving an example. Now, this is unique number 2. So that's the same exact. So this one, we ended up with n squared, right? Okay, let's take a look at this one, guys. This is the same exact program, but doing from a different algorithm. Who can solve this? Try.
So, and that's the highest order one. So, say it's M log n.
Okay, very good. James, you want to have the same answer? Okay. Who wants to solve this? Let's in the previous lecture, what did I mention to you guys? That I love what? Wrong answers. So far, it's all correct answers.
Yeah, so start the simple function by sorting, and that's what's all. Then we only have one that goes with eight times. It's like will be n log n plus n. That was sorted over the data.
Okay. Who else? James.
This isn't necessarily an answer, but with the loop not matter because it's going to return on the first iteration anyway.
Let's see.
Oh, actually, that's best case.
You had your hand raised. Who had his hand raised here? Yes.
You said n log n plus n. Was it highest one?
True, because from 0 till n minus 1 is actually from 0 till n minus 2. So it's running n minus 1 time. Till now, I didn't hear a satisfying answer. Some of the answers are true, but they are not. Yes? O of n? Why? We only care about the loop. Okay. Who else? Very good. Finally. So guys, I told you the first step, we want to look at the algorithm and understand it. There is something called arrays.copy of. How did you know this is of one or of what? That's the first thing. The second thing, there is a sorting one here. Some of you did something good if you were in the exam. And I didn't give you any sorting, you're going to assume that maybe he's talking about the best sorting algorithm, which is n log n. But I'm here, I'm still alive. You can ask me, which sorting algorithm? Why? Because if you are building this, guys, please focus with me. If you are building this, again, you're a computer scientist, you're going to be building this for a client, right? So the first step, you're going to ask for the requirements for all of these things. For example, you want to know what type of sorting you're going to do, what type of data. So the first thing you need to have, should have asked me what type of sorting you're doing here. If I told you we're doing insertion sort, it's going to be n squared. If I told you it's going to be merge sort, n log n. Now in the exam, again, if I don't give you any clue, you're going to write for me. I'm assuming this is a n log n. Now, what about the array.copy of data n? Who wants to tell me what would this be? Taha.
Basically, we are going to check if there is any duplicate here. So first we're sorting it. So if we think about it, like the items are sorted, two duplicates is gonna be together. Like no matter where they are in the array sorted. So they're gonna come like one after each other, the other. So let's say that like the best case is gonna be the first two of them, they're the duplicates. So you get them in the beginning. And
But before even that, int temp equal what? Arrays.copy of data n. We're not doing any sorting yet. So just this line.
yeah, so
What do you think? Just this line, yeah. Yeah,
So it's gonna be n.
exactly. So the first thing that we want to know is that this line, guys, we're copying n numbers into temp. So that means how many times I'm doing this? N times. So that's by itself is n. Now, array.sort, I'm going to say, let's say, n log n. And then now, whatever is inside this loop, let's say, whatever, let's say it's n or n minus 1, okay? What's going to happen here? So I have n log n, and then let's say I have n or n minus 1, whatever. So what is the final answer? Yes? Why? Very close. So because they are not nested, you don't have to multiply them. So it's going to be plus. But remember what we said last session. N log n is one thing. Yeah. So we have what? We have log n, and then after that n log n, and then n square. So what is the highest now? N log n. So n plus n log n plus n, they are not nested, is going to be O of n log n. Good? Okay, so now, which one is going to choose? So which one are you going to use? The n square one or the n log n one? They are doing the same thing. Both of them, both of these algorithms are building the same program. One of them runs n log n, and the other one runs n square. Who is going to choose the n square one? Raise your hand. Who wants to choose the n log n? Exactly. So now we have another example here. So let's take a look at this one, guys. Both of them are also doing the same exact thing. I want to analyze them. Yes.
Why do we talk about pluses?
No, because technically you want. So here you want the algorithm, the big O of the whole program. So you broke down this program. So this piece takes n time, this piece takes n log n, the other piece takes n. So you have to put them together now to know what is the total time. The total time is n plus n log n plus n. So technically it's 2n plus n log n. You can say this, you can say that, but usually when you want to use the big O notation, we say we just use the largest one from them. But technically the exact running time is n plus n log n. That's the exact one. Okay. So now this one, guys, the first one who wants to do it, I want someone again, please, someone who didn't participate. The first assignment is Thursday. So if you're still confused, let's practice together. Go ahead. First one. So one loop. Actually, yes, but here in this algorithm, we're going to treat it as n. But yes, actually, you're right technically. But from an algorithmic perspective, so you're going to be right when we execute this. So when we implement it, I'm going to put something, right, for the n. But now, from this, it's still n. Okay, so that means going from 0 till n minus 1, which means it is going to take what? N. Why n? Because we have linear. Very good. What about the second one? Who wants to do the second one? Who's engineering here? Engineering. You want to say you're engineering, but you want to participate, right? Okay. Engineering. Yes. Log n. Can you raise your voice? Sorry. Okay. Tell me why it is O of log n. So it's going from 0 till n, right? And then we have this one. So why is this log n? You don't have to have a right answer. Just like the way you thought about it, tell me the process that how you thought about it so I can correct you. Guys, please. Okay, so look what happened here, guys. Very good. Thank you so much. So here, if I'm having j plus equal to 2, so each time I'm adding 2, that means going to take what? N or what? Half. He's saying n over 2. So you're right, but n over 2 is not logarithmic. It's technically what? N over 2. So it's n times 1 over 2. What do I take usually as big O of what? Big O of n still. It's not logarithmic. It's going to be logarithmic if it's time. If I have here j time equal to 2, that's logarithmic. Very good. Thank you so much. So, guys, is it clear why this is not logarithmic? Look here. Example 2 is n over 2. It's not logarithmic because it's still n times 1 over 2. It's still O of n. Yes, right.
But if it was divided by 2, like it's equal to itself divided by 2, then it would be logarithmic, right?
Yes, it has to be not divided, multiplied, because we're starting from 0 till n, so it has to be multiplied by 2 to skip doubling, okay? Yes. Okay, so what are we doing here? We want to know how many times we executed this one, right? So what are we saying? Let's take this example here. I need to do n steps. Again, n steps. Let's say I need to do 10 steps, 10. If I'm doing j plus plus, how am I doing it? 1, 2, 3, 4, 5, 10. So how many times? 10 steps. Now if I'm doing j plus equal to, so how am I going to do it? 0, 2, 5 steps. So that means it's going to take n over 2, 10 over 2, it's 5. So half the time, but still not logarithmic. It's just half the time. Yes.
Well, the very still have to skip because array dot length is still here. But with the length array.
No, array.length is a primitive operation. You call it, it just give you. You don't have to. Why? Because this is an array, you know the indexes. But that's very good thing. Do you see? That's how I want you to think, guys. Dissect everything. Now, very good. Let's do this one more time so we can get the table clicking, and then I'll leave you in peace, and you will also leave me in peace. Okay, so guys, the first one. I'm going to go and choose someone randomly, or someone will volunteer, sacrifice themselves. Yes.
You go to the first one, and it's n.
I don't want to. What did we learn?
Okay. This one loop is n.
How many loops do I have?
You have 2.
2. Are they nested?
They're nested.
Okay. What's the next thing that I look at for?
It's n. It's linear. The second one, it's dependent on the first one.
Very good. So we don't even say the first one is linear. We go right away. How many loops? Nested, and then we check if they are dependent or not. So very good. The second one is dependent. Very good, guys. So what should we do then? The table method. Table method. Why we're doing the table method? We have J here. Okay, so let's do the table method. The sooner we do it, the sooner we'll leave. Who wants to do it? Again, doesn't have to be right, guys. Just try it. Yes. So what is the first iteration? You have a question? Yes. Very good. So the word always, no, it's not accurate. I'm teaching you this method. Again, let's say you at home, you have your own method. If it's correct, that's fine. Let's say online, you found a different method, that's fine. I'm teaching you this method because this is the most systematic one that it's super rare for you to make a mistake with this one. But there is other methods, of course. You can even look at it and do it like that. You don't even have to do the thing. But again, I'm teaching you this, and it's up to you to use it or to risk it and use something else, okay? So the first iteration, J is equal to what? Who wants to tell me? Yes. J equal to 1 or? So this is J. J equal to what? 0. Very good. Now, the second one is going to be what? So J equal to 0. I enter this loop. So what is going to be K? 0 again. Okay, how many times it's going to loop K? Which is what? Here, J is 0, so it's not going to loop. Right? Do we know why it's not going to loop? K has to be less or equal than J. J is equal to 0. So what's going to happen? 0, 0. Or technically, it's going to loop one time because we started by 0. So it looped one time. Now, what is the next step? So I'm done from this. I need to go back to the first loop. What is the first loop now? J equal 1. And then K is going to be from 0 till 1. So that means 0 and then another 1, that's 2 times. Okay. Now I want you to do it yourself. What is the third iteration, guys? I want someone who didn't participate. Someone who's still confused about it. Yes. J equal 3. And then what, K? Okay, so actually J equal 2, right? And then K is going to start with 0, and then 1, and then 2, and then three. It's only going to stop at 3, right? Sorry, 2, I mean. So 0, 1, 2. Why? Because it's going to stop at J. Okay, so now J is going to stop where? N minus 1, right? That means K is going to be for what, guys? 0, 1, 2 is going to stop when? At N minus 1. This is wrong. From 0 till N minus 1, that means this is N, not N minus 1, right? So now who can tell me what is the total big O of this program? New people. Yes. O of N? Let's do it together. Why you chose O of N? Very good. Do you see why I need to hear your answers, guys? In the table method, we don't apply the method of the plus. We actually add them up. So if I'm just checking here, if I'm checking the algorithm, if I have something to add, like for example here, if I'm looking at here and I have, let's say, n here, n here, n here, 1, I have 2 here, I'm going to say n plus n plus n plus 1 plus 2, right? And I'm going to take the n. That's here. But when I'm doing the table method, I switch to math. So then that means I'm going to add them up. So it's going to be 1 plus 2 plus 3 plus n. This has to be a math equation now. What is this math equation from previous? We said when you have 1 plus 2 plus 3 plus n. Yes. So this is wrong again. This should be n. And then here it should be n plus 1 in this case. So I'm end up of n square. Now again, guys, if you look at this, you may be able to actually just by looking at it, you say this is going to be n squared. That's fine, that's okay. Because this is a bit simple, but sometimes it's a bit more complicated, so you can go with the table. Again, in the exam, I'm not going to ask you to prove it in the table. I just need the answer, but I'm just giving you this from my previous experience. The first time I taught this class, I didn't give the table one. And I noticed there's lots of mistakes usually. So I start giving the table method just in case you find it easy. Yes. Here? Okay, very good. So guys, why here it's n times? So if I go from 1 till n minus 1, that's how many times? So look, if I go from 1 till n, that's how many times? It's n times, right? If I want to go from 1 till 10, so it's going to take me 10 times. So I'm 1, 2, 3, 4, right? Okay. So from 1 to n minus 1 is going to be equal to n minus 1. But if I start at 0, also I'm counting 0. So it's going to be n minus 1 plus another iteration called 0. So it's going to be n. Why are we saying this, guys? Why do we say we are going to count the 0? What do we mean by this? Look at this. So this algorithm is going to use a data structure like what? An array. The index of the array, sometimes we start with 0. So that means the first one here, the index is 0 like this one, but technically it is an actual box, but we just started by 0. So if I in general, I want you to always think like this. If you start from 0, so this is going to be n. So the numbers inside the data structure, the numbers inside the array are n, always n, because I don't know them, they are n. Now, if I chose, don't tell me why it's 0, because you chose it, you program it as 0. If you chose 0, that means the last number here is going to be what? N minus 1. Why? Because the total has to always be n. So if you start from 0, it's going to n, the length going to be n minus 1. If you choose to start from 1, the length will be n, the last one. Review the slides of the arrays and linked list if you're still confused about this, okay? So let's very quickly do this one, guys. 1, 2, 3. 3 nested loops. Are they dependent? Yes, these two are dependent on each other, but we already solved them, right? So this one, it's n squared. I know it, I solved it. This one is what? From 0 till n. N. So now what do I add or do I multiply? Multiply. So n cube. This one, you can just check it at home. There's nothing. Okay? And that's it. Thank you. Have a good night. There's no need. There's no need. I want this clap after the midterm and after the final. I will clap for you guys. Okay? It's deal. Okay, let me just 1 second. Let me just 1 second.